Hey YouTube, welcome to episode 12. Today we're going to look at straight line graphs. Let's get right into it. First thing we're going to look at is gradients. So the line joining 5 minus 3 to minus 1k has gradient minus 6. Work out the value of k. So the way I like to work out gradients is instead of thinking of it as the y2 minus y1 formula, what I do to avoid any negative mistakes is I line up the coordinates and read it as column subtraction. So 5 minus minus 1 is 6, minus 3 minus k. So the reason I don't like the y2 minus y1 formula is when you have negatives involved, when you have to do, for example, 5 minus minus 1, students accidentally say 5 minus 1. So they forget to write the double negative. Whereas if you write as a column like this, you avoid that mistake. Now we know the gradient is the change in y divided by the change in x. So the change in y divided by the change in x, and they've said that equals minus 6. Times through by the denominator, move the minus k overs, add the 36 over, k is 33. So how do we find the equation of a straight line? We know from GCSE that we use y equals mx plus c, but there's a formula that is more useful because we can use it given any single point, whereas y equals mx plus c is more specific to when you know the y-intercept, although given any point you can still use it. But when you have gradients that are fractions, this equation that we're going to derive is much more helpful and it allows us to solve problems a lot more easier. So let's derive that general formula of a straight line given any point rather than where it crosses the y-axis. Now, I'm going to give us a point x1, y1. That is a point that we know. xy is a general point on the line, so that can move. That could be anywhere it wants on the line. What we do know is that because it's a straight line, the gradient between these 2 points is fixed. Yes, the gradient between those two would be m. So let's find the gradient between them. We subtract the coordinates. So we'll do xy minus x1, y1. So we'd have x minus x1 and y minus y1. So the gradient m is the change in y divided by the change in x. Now what we do is we just times through by the denominator. So we put a bracket and multiply it through. And this is the general formula for a straight line, which means if you know a coordinate, you just sub it in as your x1, y1, and then you're done, basically. So there's nothing more else you need to do apart from expand brackets potentially. So let's see how it works in practice. So find the equation of the line that goes through minus 2, 7 and its gradient 3. And we're going to do it using the method you might have learned at GCSE. And then we're going to do it using the new formula. So if we use y equals mx plus c for part 1, then they've told us that the gradient is 3 already. So it's 3x plus c. Then we're going to sub in minus 2, 7. So the y coordinate is 7. Then we have 3 lots of minus 2 plus c. So we have 7 is minus 6 plus c. So c is 13. So our equation is y equals 3x plus 13. Now using the second way, y minus y1 is m, x minus x1. y1 is 7. So it'll be y minus 7 is m, the gradient is 3, x minus, now x1 is minus 2 here, so the double negative makes it plus. Then all we have to do is expand. So y minus 7 is 3x plus 6, and then we add the 7 over, and we get the same answer. Now, generally speaking, this equation will require less steps, but it's mostly useful when we deal with fractions. So find in each case the equation of the straight line with the following conditions using y minus y1. Leave your answer in the form ax plus by plus c is 0. So we're just going to make those substitutions straight away. So we have the point, so we have the gradient 2/5 and it goes through minus 3, 5. So we're going to say y minus 5 is the gradient 2/5, x minus minus 3, which becomes plus 3. Now, this is where it becomes really useful. When we have fractions like this, we want to get rid of those fractions right now. So we're going to times everything by 5. 2/5 times 5, the 5's just cancel. Now, On the right side, there's only ever one term. So when you multiply through by the denominator, it only disappears from the gradient. Nothing else gets affected. So we're left with 5y minus 25. And because the 5 cancelled, we have 2x plus 6. Now they want it in the form ax plus by plus c is 0. So you just move everything to one side and make equal 0. I like to move everything to the left side. That's just habit. So 5y, 2x goes to the other side to make minus 2x. 6 goes to the other side, so we do minus 25 minus 6 is minus 31 is 0. Now for part B, we've been given the coordinates, both coordinates, so we need to find what the gradient is first. So we line up the coordinates and make the subtraction. 7 minus 2, 5. 0 minus minus 1.5 would become positive 1.5. So the gradient is the change in y divided by the change in x. Now I prefer if we just double top and bottom here, so we're going to get 3 over 10. So now we can do y minus y1. And when you get given the option of coordinates, it doesn't matter which one you use because both of those coordinates were used to find the gradient, right? So you can use any of these coordinates. You obviously want to use 7, 0 because it's got a 0 in there. So it'll be y minus y1. Well, that 0 is the gradient x minus 7. Y minus 0 doesn't do anything. We only need to times both sides by 10 here then. So you have 10y. The 10's cancel. 3x minus 21. Then move everything to the left. Is our solution. This is applied to an exam question. It says a straight line L has gradient minus 3 and passes through the point with coordinates 3 minus 5. Find an equation for L. So we're going to do y minus y1. Well, y1 here is minus 5. So the double minus makes it y plus 5. The gradient is minus 3. X minus x1 is 3. Multiply this out. Now they haven't specified the form, but because y is on its own, let's move that over there. I would say you want to leave your line in the form ax plus by plus c is 0 when the gradient is a fraction. If it's a whole number, just rearrange it for y, like y equals mx plus c. Yeah. So for part B, the straight line M passes through the points with coordinates minus 1, minus 2, and 4, 1. Find the equation in the form ax plus by plus c is 0, where a, b, and c are integers. So I'm already predicting that the gradient between these two coordinates are going to be a fraction. So I always put the coordinate with most positives on the top. So it's 4 minus minus 1 is 5. 1 minus minus 2 is 3. And there we go, the gradient there is 3/5. Coming up here, we're going to do y minus y1. Use whichever one you want. I'm just going to use the top one. Y minus y1 is 1. Is the gradient 3/5. X minus x1 is 4. Times everything by 5. So this 5 cancels here. We're left with 5y minus 5 is 3x minus 12. Then we move everything to one side. Is 0. Finally, part C. The lines L and M intersect at P. Find the coordinates of P. So this is just language. Whenever you see the word intersect, you think simultaneous equations. So make sure you remember that. Whenever you see the word intersect in maths, your immediate response should be simultaneous equations. So we're doing simultaneous equations between what we have in part A and what we have in part B. So the y is just going to go in there. So we'll have 5 lots of minus 3x plus 4. Minus 3x plus 7 is 0. So we have minus 15x plus 20. Minus 3x plus 7 is 0. Minus 15 minus 3, we have minus 18x. 20 plus 7 plus 27 is 0. 18x goes to the other side. Divided by 18. 3 over 2. Now we're going to sub it back in to y equals minus 3x plus 4. So I'm just going to remember 3 over 2, and then we're going to sub into minus 3x plus 4. Minus 3 lots of the answer plus 4. So minus half. So we have 3 over 2. We have 3 over 2. And y equals minus 1 half. So the point P here is 3 over 2 and minus a half. So guys, that was the first part to my straight line graphs. Stay tuned for the next episode where we're going to look at perpendicular lines. We're going to apply it to some exam questions as well. If you learned something, please hit the like button. And if you want to see more maths content, consider subscribing. And I look forward to seeing you guys in my next video. Peace.